All right, so we're going to look at Descartes' rule of signs. Now, this isn't really that difficult to do, but it's pretty interesting, and it tells us a lot about our function that we're dealing with. So let's look at this and at two different examples and see what we find out. And I'll walk you through Descartes' rule of signs. Okay, so now the first thing you do is just deal with the function itself, just p of x. So rather than writing on the function here, I'm going to rewrite it. So we have for a, p of x equals x to the fourth minus 5x cubed plus 5x squared plus 5x minus 6. All right, so what we're interested in for Descartes' rule of signs is we're looking at how many sign changes from one term to the next. So from one term to the next, we want to know how many sign changes do we have. All right, so as we can see, well, first off, you want to make sure that that it is in standard form. So as we can see, it's in descending order of powers. That's good. All right, now we want to look at the sign changes. Notice that this has a coefficient of 1 if it's not written in front, and it's a positive one. It's not negative x to the fourth, it's positive x to the fourth. So this goes from a positive, and now this becomes a negative, because it's negative 5, and then it becomes positive, and then this is positive, because it's positive 5x squared, positive 5x, so it's positive, positive, and then it's negative 6. So negative. Notice that we have one sign change, two sign changes, not here, nothing here, and then because it goes from positive to positive, so that's not a sign change, and then it goes from positive to negative. We have three sign changes here when we deal with the function p of x. So when you're dealing with a function of p of x, that's telling you the number of positive real zeros that are possible. So, so since we have three different sign changes for p of x, we have two possibilities. We have either three, so again, we're dealing with the number of positive real zeros. So when I say positive real zeros, and if you want to review zeros, go back to the previous slide. But when I refer to positive, I mean like for example, x equals 3 or 5 or 7 or 2 or whatever. So a positive real zero, opposed to a negative real zero, which is like any negative number that's a zero. So so the number of positive real zeros based off of having three sign changes for p of x, we can either have 3, instead of a comma, I'll say or 1. And the way I got this is you just subtract 2 until you run out of whole numbers or natural numbers. So we have 3, and then we subtract 2 and get 1. And then we subtract 2 again, we get -1. We can't have a negative amount of something. So it's 3 or 1 positive real zeros. So guarantee we're going to have a positive real zero. It's going to be either 1 or 3 quantity, that many real zeros. Okay, so now let's go ahead and look at the amount of negative real zeros. To find the amount of negative real zeros, we're going to be looking at p of negative x. All right, so p of negative x, we want to plug in negative x into the function. Oh. Negative x cubed. So wherever you see an x, we're substituting negative x in parentheses. 5 negative x squared plus 5 negative x minus 6. All right, so we want to simplify this and see what it's equal to. So this becomes x to the fourth since it's an even power, And then this becomes, that will make 5x cubed, because we know negative x cubed is negative, and negative times a negative is positive. And then this will turn into x squared. Negative x squared is x squared, so this is still positive. And then negative 5x and minus 6. So you'll notice anything with an even power, you'll keep the same sign. So notice we had x to the fourth before, and we still have x to the fourth. And whenever you have an odd power raised to and you're plugging in negative 6, the sign will just change, negative to positive. Something you'll notice if you compare p of x to p of negative x. Now let's see, we have a positive, because we have a coefficient of 1 here, positive 1, and then this is positive from positive 5, and then this is positive, this is negative, this is negative. So we don't have a sign change there, no sign change there. We have one sign change here, and no sign change here. So this tells us the number of negative real zeros. And as you can see, we only have one sign change. So that tells us, again, the amount of negative real zeros, that like negative 3, negative 5, if those were zeros, those are negative zeros. We can only have in total one. And we're talking about quantity, not the what zero. We're not saying x equals 1 is a 0. We're saying there's going to be one quantity, negative real zeros. And that's the only possibility. We know we're going to have exactly 1. And when we subtract 2, we have negative 1. So the only possibility is 1. We're guaranteed going to have 1. All right, so that's all that Descartes' rule of signs tells us, is how many zeros we're going to have. It doesn't tell us what the zeros are. It just tells us in the end how many positive or negative real zeros we're going to have. And that's it. We're done with A. That's all that this is telling us. So hopefully this procedure makes sense. I'll go on to B. I'm going to do that in a separate video though. So just because we're already at about 7.5 minutes. Okay.